Ensoftec has developed a series of videos for the selection and design of stormwater facilities for land disturbance projects. In this video, I shall show you the design of rainwater harvesting using SWMSOFTVA. Rainwater harvesting is the simple collection, or storing of water through techniques from the areas where the rain falls and utilizing the same for agricultural, residential or industrial purposes. The collection and storing techniques include above-ground or underground storage tanks, circular or elliptical pipes, cisterns or drums. Some of the non-potable uses of the stored water may include toilets and urinals, chilled water cooling towers, landscape irrigation, car washes, street sweepers, fire trucks, fire suppression or sprinkler systems, water fountains, and laundry. The runoff reduction depends upon the type of use of the stored runoff. The runoff reduction credit can be applied by the user after approval by the agency. Credits up to a maximum of 90% can be taken if all 1 inch or less storm runoff is held in these facilities and is used through demand. The storage facilities should be sized such that no overflow occurs for these floods. There are programs and spreadsheets to enable computation of this credit. The performance, design and installation of rainwater harvesting facilities, their construction and maintenance are outlined in Virginia Department of Conservation and Recreation, or DCR Specification Number 6. The following pictures are from these specifications. Table 6.1 gives a summary of stormwater functions provided by rainwater harvesting. While specially manufactured facilities can provide a higher nutrient removal rate, nutrient removal is generally the same as the runoff reduction credit available for the facility. The contributing drainage area, CDA, to the cistern is the impervious area draining to the tank. Drainage from rooftops and with appropriate treatment, parking lots and other paved areas can be used subject to the approval by the locality. The DCR specifications give 3 configurations for rainwater harvesting. Configuration 1, year-round indoor use with optional seasonal outdoor use. Configuration 2, seasonal outdoor use and approved year-round secondary runoff reduction practice, and Configuration 3, year-round indoor use, seasonal outdoor irrigation, and non-seasonal treatment in a secondary runoff reduction practice. The tank design including storage volumes, location and size of water quality orifices, overflow weir and required freeboard are dependent on these configurations. Let me open a project and go to the BMP design. I am going to use the example project that we created earlier. BMP1 of Outfall 1 for HUC02 is a rainwater harvesting facility. I go to File, Design BMP Facility. This opens the rainwater harvesting design screen. You will notice that the required storage volume is already populated on the right side of the screen. There are 4 tank or cistern options available. They are circular, elliptical or rectangular tanks and circular cisterns or drums. There are radio buttons against each. I select the shape applicable to this project. Next, I enter the details of the tank that I have selected. If this is a circular tank, I enter the diameter, the number of tanks, and their length. If this is an elliptical or rectangular tank, I enter its width and height, the number of tanks, and their length. If this is a drum, I enter the base diameter of the drum, the number of drums, and their height. All these facilities are expected to be on level ground. So, I enter the invert elevation and the freeboard to be applied. Having entered the above information, I click on Design. You will notice that the program calculates the areas and cumulative volumes both in cubic feet and in acre-feet for incremental elevations from the invert elevation to the FOP of the facility. It will also give the elevation inside the facility for the required storage volume and the volume provided at the given freeboard elevation. The remarks will let us know if the design is satisfactory or not. I can click on Clear and start all over again. I go to the top menu bar and click on File, Save. This will save all the data including the results. I now go to the top menu bar and click on File, Print. The print report, which is an Excel format, gives the results of analysis. There are situations where the rainwater harvesting facility is designed as an offline facility, where the water quality discharge is directed to secondary practices like rooftop disconnection, vegetated filter strip, grass channel, infiltration and micro-infiltration, microbial-retention, stormwater planter, dry swale and underground infiltration soak-away pit. These are provided as part of the treatment train, to help achieve the desired treatment credit, when demand is not enough to sufficiently draw water levels in the tank down between storm events. Low-flow diversions or flow splitters in the form of a weir, or curb opening sized for the treatment volume help minimize clogging and reduce the maintenance frequency. The program lets us design flow splitters. For this, I go to File, Splitter Design. This opens the flow splitter bypass worksheet. You will notice that the water quality discharge and 10-year peak discharge are already populated in the form. I enter the bottom width of the concrete flume or the curb cut at the top and the length of bypass weir, to convey the 10-year flow. When I click on Compute, the program calculates the hydraulic head required to divert the water quality discharge to the facility and the hydraulic head required to divert the 10-year flow away from the facility. I enter the heights provided, and go to the top menu bar and click on File, Save. This will save all the data including results of analysis. I go to the top menu bar and click on File, Print. The print report, which is in Excel format, gives the results of analysis. This completes the design of rainwater harvesting methods.